The magnetic dipole, a journey from butterfly wings to the quantum heart. Discover how a simple magnetic source creates a complex, infinite loop of energy that defines everything from household magnets to the distant signals of the cosmos. Imagine a tiny, constant magnetic source known as a dipole moment. This source generates a surrounding influence called a vector potential, which serves as the mathematical map we use to calculate the actual magnetic field. When we observe this field from a distance, it reveals a beautiful and iconic butterfly pattern. The field lines curve gracefully through space, flowing out from the North Pole and looping back toward the South Pole. If you were to measure the spin or curl of this field in the empty space surrounding the magnet, you would find it is zero, confirming that no electrical currents are flowing in that empty region. Visualizing the flow. The butterfly demo. To see this in action, consider a digital simulation that traces the magnetic path using thousands of tiny particles. This demonstration shows that the field is composed of two distinct parts, one pushing radially outward and another pulling parallel to the magnet's orientation. Together, they create continuous looping lines that grow weaker as you move further away. The simulation uses logarithmic mapping to show how the strength changes, highlighting the intense pull near the source compared to the faint influence further out. The mystery of the center, the upward snap. A fascinating puzzle arises when we try to look at the very center of the magnet. In a purely theoretical model, the field appears to become infinite at that single point, which creates a mathematical singularity. To resolve this and remain physically accurate, we must treat the magnet not as a single point, but as a tiny loop of electric current. In a second, more advanced demonstration, we see that the field lines do not simply vanish at the origin. Because magnetic field lines must always form closed loops with no beginning or end, the field must snap upward through the very heart of the magnet. While the field outside the magnet flows downward from north to south, the field inside shoots upward with incredible intensity to complete the circuit. This ensures that every line exiting the North Pole eventually returns through the center, fulfilling the fundamental requirement that there are no sources or sinks in magnetism. From theory to the stars. This snap at the center isn't just a technical detail. It has profound real-world consequences in quantum mechanics. This intense internal field is